Welcome to this session by Dr. J.K. Sachdeva on data visualization with R. In this lecture, we will explore how to visualize data using R, one of the most powerful languages for statistical analysis and graphical representation. Data visualization is a crucial step in any analysis process. It helps us to summarize, interpret, and communicate our data effectively. R provides two primary ways to visualize data, using base R plotting functions, and using the GPLO2 package, which is part of the tidyverse. In this lecture, we will learn to create various types of charts. Bar chart, pie chart, line chart, scatter plot, histogram, box plot. Data visualization transforms complex data into clear, visual insights, enabling faster understanding, better decisions, and more effective communication. Let's begin with the first visualization, the bar chart. Bar chart in base R. Let's begin with a simple bar chart in base R. Here, we first create two vectors, one for counts and another for category names. The bar plot function is used to plot the data. Notice the arguments. Names.arg assigns the labels on the x-axis. Kernel controls the color of the bars. Main, xlb, and elab define the title and axis labels. When I run this in RStudio, you'll see a blue bar chart showing each category's count. This is ideal for simple comparisons, say, survey responses or sales across regions. Bar chart in GPLO2. Now, let's move to a bar chart using GPLO2. We start by loading the library using library, GPLO2. Next, we define a small dataset inside a data.frame. This is how GPLO2 expects data. Inside the GPLO2 function, we map category to the x-axis, value to the y-axis, and fill for color. The geom_bar layer actually draws the bars, and the argument stat is equal to identity tells R to use our actual values instead of counting observations. Finally, we add a title and a clean theme using theme_minimal. When executed, the output shows colorful bars, one for each category, with modern styling. This version is perfect when you are preparing visuals for research papers or presentations. Pie chart in base R. Next, let's look at pie charts using base R. First, we create the numeric values in slices and assign category labels in labels. Then we calculate percentages by dividing each slice by the total and multiplying by 100. The paste function helps us combine labels with percentages, giving a clear display like a 25%. Finally, pie draws the chart, and the rainbow function automatically generates bright, distinct colors. When this runs, you'll see a classic pie chart that immediately communicates proportions at a glance. Use pie charts for showing share or composition, like market shares or budget breakdowns. Pie chart in GPLO2. GPLO2 doesn't have a dedicated pie chart function, instead, it cleverly uses polar coordinates. Here, we build a small data frame with categories and their values. Inside GPLO2, we leave the x-axis empty, x is equal to, since pie charts don't need it, and map values to the y-axis. The geom_bar function first stacks the data as bars, and then code_polar, theta is equal to y, bends it into a circular pie. The result is a very clean, customizable pie chart, great for modern dashboards or reports. You can change the theme, labels, or color palette to suit your branding. Line chart in base R. Let's now explore line charts, which are ideal for showing changes over time. We define a sequence of values for x and corresponding y values. In plot, we use type is equal to O, which stands for overplotted points. It connects the data points with lines while keeping markers visible. This combination makes it easy to visualize both individual data points and the overall trend. When we run the code, we'll see a simple blue line with circles marking each data point, a great way to show time-based progress, like monthly revenue or yearly growth. Line chart in GPLoad2. GPLoad2 lets us enhance this visualization. Again, we start with a small dataset where each row represents a time value pair. Using geom_line, we draw the trend line, and geom_point adds the data markers. The labs function customizes titles and axis labels, while theme_light applies a clean visual style. As soon as you run this code, you'll see a red trend line with points overlaid, very clean and professional. Line charts like these are essential in financial, economic, or scientific data presentations. Scatter plot. Scatter plots are used to show relationships between two continuous variables. In base R, we define two numeric vectors, x and y, and use the plot function. The PCH parameter controls the shape of the points. Here, we use 19 for solid circles, and kernel sets their color. When we run this, we'll see the points forming a general upward trend, suggesting a positive correlation between x and y. Now, using GPLoad2, we wrap the data in a data frame and use geom_point to draw the points. Adding geom_smooth method is equal to LM fits a linear regression line, helping visualize correlation strength. This is particularly useful in regression analysis, where you want to see if two variables move together. Histogram. A histogram displays how data are distributed across intervals or bins. We start by generating random numbers using rnorm 1000, which produces 1000 values from a normal distribution. The hist function then groups them into bins automatically and displays their frequencies. You can modify colors, labels, and borders for a cleaner look. When run, you'll see a bell-shaped curve typical of normally distributed data. Now, with GPLoad2, we create a data frame and map the variable to the x-axis. The geom_histogram layer builds the histogram, and the argument bin width is equal to 0.5 controls how wide each bin is. Adjusting bin width is crucial. Smaller bins reveal more detail, while larger bins smooth the pattern. Box plot. The box plot is one of the most informative visualizations for statistical comparison. In base R, we use the box plot function with three groups, A, B, and C, each containing normally distributed random data. The colors make each box distinct, while axis labels describe the data. The horizontal line inside each box shows the median. The box itself covers the middle 50% of values, and dots outside the box represent outliers. The GPLoad2 version uses a tidy data frame with two columns, group and value. Geom_boxplot automatically detects the quartiles and outliers, producing a professional-looking comparison chart. Box plots are particularly useful when comparing data from different treatments, methods, or samples. Conclusion. To summarize, we've covered 6 powerful chart types in R. Bar charts for category comparison. Pie charts for proportions. Line charts for time trends. Scatter plots for relationships. Histograms for distributions. Box plots for data spread and outliers. You've also seen how Bezier offers simplicity, while GPLO2 provides customization and aesthetic control. As you practice in RStudio, try modifying colors, themes, and datasets to develop your visual storytelling skills. Thanks for watching and subscribing. Thank you for following along. Happy coding and visualizing.